Okay, class, good morning. So, again, let us now proceed to the next topic in thermodynamics. So, this is under the processes of vapor. So, this time class, I will give you the process which is at constant temperature. So, previously, we already discussed about if the pressure is considered constant. So, by this time, we are now going to consider if temperature is considered constant. So, class, so this is very similar to the previous discussion. So, for this is not for constant pressure, but it is for constant temperature. So, take note, class, okay? So, you can change pressure here to temperature. So for the PVT relation, so by just looking at the figure, so, in getting the enthalpy, so that is equal to the enthalpy of the liquid plus the quality of the steam multiplied by the quality enthalpy rather of the mixture. Okay? So, the discussion of this class is very short. Okay, so for reversible non-flow, so again, this is constant temperature process. So, you change again this class. So, the work non-flow is just equal to the heat transfer multiplied by the, or minus rather, the change in internal energy. Okay? And for the heat transferred, so for simple energy equation, Q is equals to T multiplied by delta S. Okay, so this is similar to the heat transferred under the ideal gas. Okay, so another for steady flow, so we have here the work steady is equals to Q minus delta H minus the change in kinetic energy if uh, the velocity and mass of the substance are already given. Okay, so that's all class. So we come now to the example. Okay, so in order for us to understand clearly the topic. Okay, 3 kilograms of steam initially at 2.5 megapascal and a temperature of 300 have 2 460 kilojoules of heat removed at constant temperature. Okay, until the quality is 90%. Okay, class, so take note that the quality, of course, is 90%, of course, at the final condition. So, determine, okay, the pressure when dry saturated steam exists and the work. Okay? So, at state 1, so that is at 2.5 megapascal and 370 degrees Celsius. So, of course, since both the pressure and temperature are already given, so we know already that the steam rather is superheated. Okay? Superheated condition of the steam. So, when dry saturated exists at 370, okay, so considering the table 1, so saturated temperature, since T equals to constant. So, at 370 degrees Celsius, P saturation now is equals to 21.03 megapascals. Okay, so this is all obtained class in the table. Okay, so take note that if you are very familiar, of course, when using the stream tables, so it is very easy for you to get, okay, or obtain the answer of course, of the questions that could be arises. Okay. So another we have here at 2.5 megapascal and 370. The internal energy is 2887. So this is kilojoules per kilogram. And then at 370 now, use of 2. Okay. So since the quality is 90%, so that is use of 2, use of F2 plus X UFG. Okay, so use of F sub 2, so that is 18,000 or 1,844 kilojoules per kilogram. UFG 384.5, and substituting values now. So use of G or use of F rather 1844 plus 90%. Okay, so multiplied by 384. So that is 2190.05. Okay, and another. So use of delta U rather. So changing now the or getting now the change in the internal energy. So subtracting. So that is 2190.05 minus 2887. So that is negative 696.95 kilojoules per kilogram. Okay. So and then getting now the non-flow work. So that is Q minus delta H. Okay. So 240 60 kilojoules, 24 rather, 60 kilojoules divided by 3 kilograms, okay, of steam. So minus the change in enthalpy. So the answer now is 1516.95. Okay. So or simply the work plan flow is 4550.85 kilojoules. Okay. So thank you very much, class. So all you have to do is to follow, of course. Just look at the given and then uh, you trace, of course, this given, of course, and steam table. So like, for example, this 2.5 and 370. So that is situated. And table 3. Okay? So, and then look for the values of UF, U sub FG, and so on and so forth. Okay? So, thank you very much, class. That's all about the presentation.